If you want to model loads and dynamics of structures, you should try Patran. Patran lets you access advanced features of MSC Nastran, such as optimization, aeroelasticity, and rotordynamics. For explicit finite element analysis, we have a solver called Dytran, and Patran is the main preprocessor for it. I will explain all of these terms soon. You should learn Patran if you want your career to eventually take you in one of these advanced finite element analysis directions. Still, the most common reason why beginners use Patran is that it is the standard for many established projects. This video is part of a series on how engineering students can get started learning simulation with Hexagon. In this video, I will tell you about how Patran is used in industry, how to spend your first hour with Patran, and how to learn more. Let's go! I will now describe some of the advanced modeling techniques that Patran lets you access. With design optimization, you can enter a starting geometry, and the solver will produce a final geometry that meets your loading requirements. Here are a couple of other examples. You often use optimization to lightweight a design. Rotordynamics addresses the motion of rotating machines with significant angular momentum. These machines are especially prone to excess vibration. Rotordynamics is often used in understanding rotating machinery in transportation, turbines, and machine tools. Aeroelasticity handles the interaction between structural loads in an aerospace structure, like an airplane or a helicopter, and the fluid flow around it. As a structure is loaded, its shape changes the fluid flow, which could then change the loading back and forth. Aeroelasticity lets us handle these things together. It is especially useful for ensuring that controls work correctly and for managing flutter. Explicit analysis is a type of finite element analysis that is especially suited for rapid motions, large deformations, and large models. We often associate explicit analysis with simulation for automotive crash, but it's also useful for other applications, such as this ship hull running aground. Patran includes a number of case study examples that you can work through. To access them, you will need to install the documentation. If you're using the Student Edition, you would have downloaded this link to get Nastran and Patran. You would simply use this link to access the Patran documentation and install it as well. Alternatively, you can go to the Nexus Documentation Center and look up Patran. Within that, you can find a case study of an annular plate, which is what we'll be discussing in this video. I will share the link for this tutorial in the description for this video. I have a couple of tips to help you get started with Patran. First, enable the model browser. Create a database, click the Home tab, and then click Model Browser. This lets you view a lot of things that are associated with your model, such as materials, loads and boundary conditions, and even results once those are ready. This is empty right now, but this list will fill as I work through the tutorial. Next, I will show you how you will complete most tasks in this case study. Now, there are a lot of buttons up in the ribbon, but we're normally not going to use those. We'll use this ribbon tab, and that opens up this application panel. From that, you will typically select your tools by this action object method paradigm. So I'm going to create a curve using the method XYZ. In general, actions in Patran are available through this action object method paradigm, and if you can think in those terms, it will make it easier to find the tools that you're looking for. Again, there are these buttons up in the ribbon, but those are generally shortcuts for what you can do through the action object method interface. Just so you get a sense of what Patran looks like in action, I'll create the geometry of the annulus for the exercise. So I'm creating one edge, and then another length 10, and offset a little bit so that this curve meets up with the previous one. See, there's one curve, and there's the first curve that I created. Next, I will create the annulus by revolving these curves. So I change the object from curve to surface, and the method to revolve. Here I'm clicking edges, and Patran is revolving those edges along angles that were set in this form. There, now I've got the geometry. For meshing, I would then go to the Meshing tab and pick the corresponding action object and method. So I want to create a mesh, a surface mesh. The other defaults here are fine for me, except I want to change the edge length. I'll select everything and click apply. And now I've got a meshed part. Now that's just the start of the case study. I want you to follow the written instructions from here, which are very clear on how you should work. You would simply click Help, Contents, and Index, and then within your web browser, you would navigate to Patran User's Guide, Introduction, a case study of an annular plate, and then you would work through these sections here. If you have trouble getting that page to load in your web browser, alternatively, you can view this same content on the Nexus Documentation Center, and a link for that is in the description for this video. With that, I will leave it to you to work the rest of the way through this case study on your own. Thank you for checking out Patran with me. To learn more, you can check out the case studies that are in the documentation. There are other examples like a lug and a coffee cup. You can go beyond that by taking Patran courses on Nexus Academy. There's a link to that in the description. If you're a student or a professor and you want to try Patran yourself for free, there are links to the student editions in the description. We also have contact information. Reach out if you have questions. And if you want to teach with Patran or other finite element software from Hexagon, let me know. I would like to see how I can help. Thanks. Have a great day. Bye.